Okay, so homeostasis associated with controlling and integrating multiple body systems so that the physiologic control and balance can be maintained. And that's just exactly what you said. It's dependent on multiple physiological processes, and an imbalance can result from a variety of conditions. And also an imbalance can affect chronic and acute illnesses, as well as chronic and acute illnesses can create an imbalance in homeostasis. Fluid and electrolyte balance, specifically because that is the concept that we're speaking of. The process of regulating extracellular fluid volume, body fluid osmolality, and we'll go over these, and plasma concentrations of electrolytes. So what do I mean by extracellular? Outside the cell proper. All right. So fluids, what constitutes fluids for us? Blood, serum, albumin, urine, bile, hormones, cerebrospinal fluid. There's lots of components. All right. Your SLOs, after reading about the concept, the student will be able to summarize the physiology of the various body systems involved in the maintenance of fluid and electrolyte balance. Differentiate common assessment procedures used to examine fluid and electrolyte balance across the lifespan. Choose important dietary sources of the key electrolytes. Maintain the management of fluid and electrolyte balance and prevention of imbalance. And use health language. I always tell my students, what's the scholarly term for that? And they've now said, what's the nursey term? But health language related to fluid and electrolyte balance in appropriate context. So the human body, and this is all a review for right now, approximately 60% of the average healthy adult's weight is water, the primary body fluid. Water is vital to our health and normal cell functioning. Medium for metabolic reactions within the cells, transporter for nutrients and waste products, and it acts as a lubricant, an insulator, and a shock absorber, and it helps to regulate and maintain body temperature. So, what happens when you don't drink enough water? You get dehydrated. How would you know you're dehydrated? Dry skin, what else? Decrease urine output. Could be, very good. What'd you say, Liz? Sluggish skin turgor. Could be tachycardia. It affects every system. Does it affect this? How do you know? How does it affect this? They get altered. Okay. Did you need to say something, or are you just busy? Okay, there you go. All right. Distribution and composition of body fluids. We're going to divide it into two major compartments, intracellular and extracellular. And you already said that anything outside of the cell is extracellular. So electrolytes are charged particles capable of conducting electricity, and thus that's how they get their name. Major cations include sodium, potassium, calcium, magnesium. You've heard of all these. Major anions, you see the little negative, include chloride, bicarbonate, phosphate, and sulfate. So both intracellular and extracellular fluids contain oxygen from the lungs, dissolved nutrients from the GI tract, products of metabolism, and ions, your charged particles. If the charged particle, and I just touched on this, if the charged particle is positive, it's referred to as a cation. And if it's negative, it's called an anion. And ideally, and this makes sense, the number of cations and anions should be the same. When you get to your acid-base lecture, I think it's primarily in senior level, you'll learn something about something called an anion gap, where you have more of one than the other. Electrolytes are generally measured in milliequivalents per liter, and you'll see that as, I don't see that there's a, but it's like a little m, a big E, a Q/L, but there are some that are measured differently. Okay. For example, calcium is measured in milligrams per deciliter. Keep in mind that laboratory blood tests are performed on extracellular fluid, so it's usually from the vasculature. All right. More about body fluids and the composition. We'll talk a little bit now about intracellular, inside the cell. Found within the cell of the cell proper, it comprises about 2/3 of the total body fluid of adults. So most of that fluid is going to be in our cell. It's vital to the cell functioning. It contains solutes such as oxygen, electrolytes, and glucose. And we all know you need glucose to function. Provides a medium in which metabolic processes of the cell take place. And we talked about, so inside the cell, and I don't want y'all to memorize this. This is not what I want you to memorize now. We'll talk about it a little bit more later. We'll expound on it. The major cations inside the cell are potassium and magnesium. Makes sense. Do you know what the normal serum potassium is? It's little, right? So if it's little in the vasculature, it makes sense that it would be bigger in the cell. Does that make sense? Okay. So it's the major cation, potassium and magnesium. The major anions would be phosphate and sulfate. So just something to think about. Extracellular, found outside the cells of the body, and it takes care of or comprises about 1/3 of the total body fluid of adults. This includes cerebrospinal fluid, pericardial fluid, pancreatic, pleural, intraocular, biliary, peritoneal, synovial fluids. So it's not just fluids that's in the interstitium or in the vasculature. But the two main compartments are intravascular and interstitial. Intravascular meaning what? In the vessels, okay? 20% contains protein. Interstitial, about 75%, mirrors the plasma minus the protein. We also have lymph and transcellular fluids, and I talked about some of the transcellular, the cerebrospinal, the pericardial, the biliary. So these extracellular fluids carry nutrients to and waste from the cells via the lymph system and the blood capillaries. All right. Homeostasis. Homeostasis is our exemplar. Intracellular fluid, fluid within the cell. Most of the body's fluids are found within the cell. What happens to the, like I said, if you don't hydrate enough, those cells can't function properly. They don't have what supports them. Extracellular, same thing. If you don't hydrate, you tend to have a collapsed vasculature. Fluid outside the cell, and it comprises the intravascular in the vessels in the form of plasma or serum, and interstitial fluid, fluid surrounding. And this is just a little picture to show you the amount of fluids and, you know, what they comprise and how most of, good morning, how most of them are going to be in the cell. And this is just another picture that just shows you the plasma. See how most everything is outside and only a small portion is actually in the vessels. The intracellular and extracellular spaces are the body's basic fluid compartments. Extracellular is further divided into intravascular and interstitial. So some definitions. An electrolyte. It's an element or a compound that when melted or dissolved in water or an other solvent, it dissociates into ions and can carry an electric current. Osmolality is a measure of the number of dissolved particles in a fluid. It's measured in the number of osmoles, and I don't want y'all to remember this. I just want you to kind of grasp the general idea of osmolality. So it measures the number of osmoles of solutes in a kilogram. The osmolality reflects the concentration of substances such as sodium, potassium, chloride, glucose, and urea in a sample of blood, urine, or sometimes even stool they'll do. Have you heard of blood osmolality and urine osmolality? Generally speaking, if your urine osmolality is high, your volume in your body's going to be, your osmolality will be low. If your urine's very, very concentrated, your blood's not going to be that concentrated. Does that make sense? Osmotic pressure. It's the power of a solution to draw water across a semi-permeable membrane. When two solutions of different solute concentrations are separated by a semi-permeable membrane, the solution of higher concentration exerts a higher osmotic pressure, and it draws water across the membrane to equalize the concentration of the solutions. So I guess my example, this is not a really good example, but between, like, say, osmosis and diffusion. This is a very vague. You have a glass of water, and you take a tea bag, and you put the tea bag in the water. When the water goes into the tea bag, it's osmosis, because it's trying to equalize. When the tea goes out, because it's a solute, not a solvent, it's what? Diffusion. So just kind of get an idea of what it is. And then osmolarity, it's the measure of concentration of osmotic solution. All right. An example of a concept map for homeostasis. So let's just look at this just a minute. All right. Regulation is by output, intake, and hormonal also plays. And imbalances could be fluid volume deficit, hypovolemia. Some of you said dehydration. Fluid volume excess, hypervolemia, and fluid overload. Has anybody had a patient yet this semester with congestive heart failure? Or it could be a personal. What did they look like? Edemic. What were their symptoms of fluid overload? Short of breath. Okay. So maintain our functions are to maintain blood volume, regulate temperature, cellular transport, digestion, and excretion. So your nursing care plan, we're going to assess the skin, the mucous membranes, the cardiovascular system, the neuro, the respiratory, the vital signs. Somebody in here talked about the dehydration and maybe their blood pressure dropping, right? What would you think about cardiovascular if the person's in overload? What kind would you say? Okay, but how could you, as a nurse, how would you know that there's an increase on that heart? Okay. What might their blood pressure be? Okay. All right. And we look on the other side. Talks about the intracellular fluids and the extracellular fluids, excess or deficits in the intracellular, extracellular. All right, just a little look at a nursing care map for fluid and electrolytes. This is just another picture about the processes that are involved. Active transport, and I don't want y'all to remember these. Active transport is the movement of ions against osmotic pressure to an area of higher pressure, and it does require energy. But the one I talked about, like with the tea bag, is diffusion. So another way I describe diffusion. What's so funny? Yeah, like a tea bag. I'm a Southern girl. But another way you can look at it is air freshener. It's in a can, and when I spray it, you can smell it up here, but it takes a while, but eventually it gets all over the room. So it's a passive movement of electrolytes or other particles from an area of higher concentration to an area of lower concentration. In osmosis, it says the movement of water. It's typically water. It's not always, but it's a solvent or another solute. I think she meant to put solvent. Movement of water from an area of lesser to one of greater. So that was the example I gave with the tea bag again, the water going into the tea bag. And then filtration would be when you take your spoon and you take that tea bag and you wring it out just to get the last bit of tea. So that's filtration, movement across the membrane under pressure from higher to lower. All right, just this. Okay. What is it? I don't know what penocytosis is. What is penocytosis? That's okay. Well, enlighten me. What is it? A bacteria? Oh, okay. We're not on that today, but sort of like phagocytosis. All right, regulating body fluids. Fluid intake. Now, this is important. Fluid intake. The average adult drinks about 1,500 milliliters of water a day. Hopefully, if you're working outdoors, if you're an athlete, it's a little bit more than that because your need would be greater. Does that make sense to you? Needs are 2,500 mils per day. Water content of our food is about 750. Let's go back to what the average adult drinks. It says the average adult drinks 1,500 milliliters a day. A soda can is 12 ounces, right? So 12 times 30 is what, 360? So 360, so it would be about, what, 4 soda cans? Is that right? About? What's 360 times 4? God bless you. We've got a calculator. 360 times 4. So that's pretty close, 1440. So about 4 soda cans. That's really not that much. But so our needs are greater. So we do get some water content from our food. And then food metabolism gives us a little bit, about 200 milliliters a day. And just a little side note on fluid intake, that our thirst center is located in our hypothalamus. Fluid output, urine output of about the same. Ideally, we would want our intake and our output to be close, would we not? I mean, it's probably never going to be equal, but we would want it to be close. So urine output's about 1,400, 1,500 a day. Sensible loss occurs through the skin and the lungs. What do I mean by insensible loss? No, it's not negligent. Respirations, would you say? Sweating, okay. And we can account, that will account for, some people say 300 to 600. So that does account for some insensible loss. And then feces, unless you're constipated, we all have some liquid. And some people have more if they have diarrhea. They can have more liquid in their stools. So, I just had a thought of a question I wanted to ask y'all. Oh, I know what it was. So, urine output, 1,400 to 1,500 a day. What should somebody's urine look like when they urinate? What did you say? Pale yellow. That's one. What else? Clear. Well, when I say clear, I mean like no debris in it and no sediment, and sometimes it happens. So it should be clear, pale yellow. Not clear, but you know what I mean, like no sediment in it. Pale yellow. What do you think of? Have you ever had a day when you've just been running errands, or you've been at school, or for me, you've been a nurse, and you realize it's and you're on a 7A to 7P shift, and you realize it's 4 o'clock, and you have not made it to the bathroom, and you go to the bathroom, and you urinate, and it's like golden, okay? And it's probably not a lot either, okay? I'm retired military. Anybody in here military? Are you military? Okay. God bless you. In the military, when you're out in the field playing war games, or when you're outside doing an exercise, it's a general rule of thumb that you drink till your pee is clear. And it's a great rule of thumb if you're outside working. One summer, I went and I wanted to do, when my daughter was little, I had a little commitment to myself that every summer she and I would do something different. Didn't have to be expensive. But one summer, I got my nursing license in North Carolina, and I went to a very posh, because I couldn't afford it. It was like $2,000 a week. I went to a very posh all-girls summer camp, and I took my daughter, and I called them up, and I said, can I come be a nurse and not get paid and let my daughter come? And they said, we do that all the time. So I brought my daughter, and we went to Asheville, and we went to Camp Hollymont. I think it's still running. And there were 4 nurses. And we had all these kids kept coming in. Basically, the signs that they were coming in with were dehydration. So they had lots of outside activities. They had archery, they had volleyball, they had golf, all this stuff. So I told the lady that ran the camp and owned the camp, I said, let's go get those big water igloo jugs. And every kid carried a cup with them. And I said, before every activity that they go to, because they like rotated, it was like class, you know, they have to drink a little cup of water. It's like, no. It's like, well, it'll keep everybody from coming to the infirmary. So a good rule of thumb when you're working outdoors is that you need extra water. But if you're going to work outdoors in construction, and hopefully y'all won't be doing that with your nursing degree, but if you're working outdoors, that you really need to drink a lot till your urine's clear. All right, maintaining homeostasis. How do we maintain homeostasis? Kidneys, primary regulator of body fluids and electrolytes. Be kind to your kidneys. This is a little bit off the beaten path, but people who do low-carb diets, a low-carb diet is essentially what? A high-protein diet. And proteins, when you eat a lot of proteins, are harsh on the kidneys. And I had a friend, this was years ago, we were both doing a low-carb diet. She lives in Washington State. And she came to the realization that she can't do a low-carb diet because when she would urinate, she'd see foam in her urine. If you see foam in your urine, it probably means you're spilling protein in your urine. So just remember that. So kidneys are our primary regulator of body fluids and electrolyte balance. They also play a role in our acid base. They play the role that deals with our hydrogen ions, all right? So antidiuretic hormone. Have you heard of ADH? All right. It's also known as vasopressin. Produced by the hypothalamus. Stored and released in the pituitary gland. If we are dehydrated, if we have a high serum osmolality, we're dehydrated. Our body will release ADH to conserve water, and consequently our urine output will decrease. And likewise, if you are in fluid overload, your ADH will not be released and water will no longer be conserved. Do you remember from A&P, did you ever hear about atrial natriuretic factor? Okay, good. Some people have not heard of atrial natriuretic factor. It inhibits the renin-angiotensin aldosterone system. I skipped over the renin. Okay, let's go back to the renin, the RAS. You'll hear it called the RAS, the renin-angiotensin aldosterone system. It regulates blood pressure and fluid balance. And insensible loss occurs through the skin and the lungs. And atrial natriuretic factor will inhibit it. So it's a hormone that's released by the atrium, the right atrium, in response to high pressure within the body. It promotes sodium and water excretion by the kidneys, and it acts as a potent diuretic. It inhibits thirst, and therefore it reduces fluid intake. All right, regulating electrolytes, maintaining fluid balance. Primary regulator of body and fluid electrolytes, what did I say that was? The kidneys. Contribute to acid-base regulation, and we're speaking now of the renin-angiotensin. The atrial, produced by the hypothalamus, stored and released in the pituitary. That's how the body releases ADH. Facilitate enzyme reactions. These are our acid-base regulation. This is our enzyme reactions. Our electrolytes in general regulate blood pressure and fluid balance. What do you think of when you think about fluid balance with electrolytes? What do you think about when you think about somebody in fluid overload? What do they usually have in their diet that they can't have? What's the other word for salt? Sodium. So facilitate enzyme reactions. They regulate blood pressure, and I'm thinking salt's probably the one that we think about the most. Insensible loss occurs through the skin and the lungs. And then our electrolytes transmit neuromuscular reactions. This is all in general. Hormone are released by the right atrium in response to high pressure, and we talked about the atrial natriuretic factor. Promotes sodium and excretion by the kidneys, acts as a potent diuretic, and inhibits thirst and reducing fluid intake. So they're kind of like opposites. Let me go back to the other page. Previous page. These two are kind of like opposites. This one's going to help us to reduce fluid intake and get rid of fluid, right? And this one's going to help us to hold on to it. Regulates blood pressure and fluid through the skin and the lungs. All right. This is something that I want you to pay attention to. In your textbook bundle, you have Pagana and Pagana, do you not? It's a lab book. Yes, somebody said yes, thank you. All right, so we'll talk a little bit about electrolytes and fluids and serum levels that you draw. All right, you'll hear it called a BMP, you'll hear it called an SMA6. Sometimes they'll do an SMA12. Sometimes they'll call it a Kim panel. Anything else you can think of they call it? Most people call it now basal metabolic. Back in the days they called it a SMA6 when I was in there. Now it's called sometimes it's an SMA7, but they call it a metabolic profile. So one of the first things that you'll see, and we just talked about this, was sodium. Sodium's going to be primarily your most abundant cation in your extracellular fluid. And I talked about the potassium being the most in the intracellular, because in the blood vessels, your potassium is like 3.5 to 5. But your sodium is your major, and you see it's a little bit bigger span. These are the lab values that I want you to use. They come from Pagana and Pagana, but I don't want you to memorize them. What I want you to do with these lab values is to get an idea of what they are, because nobody's going to ask you, the patient's creatinine is 1.0. Is it normal or is it abnormal? We're not going to ask you that. We might give you a scenario where we give you somebody's lab values, and then we're going to say, what would you do? Well, you've got to then know what the normals are. So we're not going to ask you normals, but the normal sodium, 136 to 145, it contributes to your serum osmolality, because what happens? What follows sodium? Water. Regulating your extracellular volume and distribution, and then dietary sources. What would be some dietary sources of sodium? I could tell you a story about that. Bacon would be a good one. Take them. Well, we'll go back. We'll do this when we finish this. We'll go back and we'll go over some ideas of dietary sources of these. Let's move on to potassium. Potassium is the major cation in the intracellular, and we talked about that. The normal value being 3.5, God bless you, to 5.0. Now, what I want you to know about this, too, in addition to I don't want you to memorize this, and the reason I don't want you to memorize this is every hospital you're going to go to is going to be different. Some places will say potassium is 3.2 to 4.8. Some will say it's 3.3 to 5.2. They're all going to be a little different. What's important for you to know, while you're in school, you need to know the Pagana and the Pagana lab values. But what's important to know is wherever you go, wherever you work, that you know what the normal is there. Because then if it's abnormal, you know you need to call the doctor. You can't say, well, when I was in school, Ms. Dawson said it was 3.5 to 5.0. If you just have to know, it's like policies and procedures. We can tell you how we do something, but you're responsible where you go to know what the policy and the procedure is. So potassium, 3.5 to 5.0 milliequivalents per liter. Transmit nerve and other electrical impulses. It's very important in skeletal, cardiac, muscle function, smooth muscle function. It does help to regulate acid base. And I want you to, if you know anything, if you leave anything about potassium, leave knowing anything about it. And you were talking about acid base when we walked in. This is a general rule. It's not always. If the potassium is up on a patient, more than likely they're going to be acidotic. When the potassium's low, they're alkalotic, and when it's high, they're acidotic. It has to be ingested daily, and we're going to do a little exercise when I finish, and we'll talk about dietary sources of these. Okay, glucose, 70 to 110. we had an incident in the nursing home. We were doing blood glucose checks, and I was walking around checking on all the students. Some were doing physical assessment, some were getting oxygen sats for the nurse, some were doing glucose check, the little finger stick. And I said, let me see what everybody's, because I'm nosy anyway, I said, let me see what everybody's glucose was. And somebody's glucose was like, it just said low. And I said, well, did you go tell the nurse? And, well, I didn't know. And I'm like, your brain works on glucose. It's much easier to treat, like to assume that they're low. If you don't know, if you've got a patient that's a diabetic, or you got a patient and you don't know what their blood sugar is, and you think it has something to do with their blood sugar, it's a lot easier to give them sugar and treat it later if you made the wrong decision and treat a high one than to give them insulin, make a bad situation worse, or not treat it. So the normal is 70 to 110, and I want you to know hypoglycemia is an emergency if they're really hypoglycemic, if they're like 40. What do y'all do when you have somebody who's low? I know what I do. What do you do? Okay. We had a patient about a year ago on the floor, and their blood glucose, we stuck it. And on our floor, and once again, everybody's floor is different. On our floor, if it's less than 40 or 50, you have to repeat it, and you have to let the nurse know, like right away, or greater than 400. That's kind of like the parameters. You expect diabetics to be 260. You expect them to run, but you never want anybody to run low. You don't eat for like 2 or 3 days, your glucose is going to be low. So the student comes to me and I said, well, let's stick them again. We stuck them again. We still got in the 40s. And the nurse is trying to get in the Pyxis to get the tablets. Don't they make those tablets? Yeah. And I said to the tablets, I said, go get 2 things of orange juice and put 3 packets of sugar in each one. I mean, she was coherent. And I said, and just make her, and stir it really well. It doesn't really dissolve, but I said, stir it really well and get her to drink it. And another thing you can do, if you have a family member who is a diabetic, it's a lot cheaper, and I was a basic. And the guy that taught us in Louisiana, he's probably not there anymore, he taught us this, and I thought it was ingenious. A lot of people can't afford the paste, cake icing, in the tube, because it's cheap and it's pure sugar. And you can put it, you can put it under their tongue, and it's the same thing, it's just about, and it's a lot cheaper. So, glucose, 70 to 110. Just remember, if you leave with anything about glucose, I want you to realize that if it's low, you need to act on it. So after we did that, we checked it again, and we called the doctor, and the trays were coming soon, but still, you don't want anybody to be like that. Another thing that I want you to leave with, the 2 notes. Hypoglycemia demands your attention. Even 60 or 70, I mean, if they get ready to eat, I wouldn't be concerned, but you want to worry about it because your brain functions on glucose. And if you let it ride and you forget, they're going to fall into a coma. And it's hard to get them back. The other thing I want you to leave knowing about glucose is back in the day when I graduated, we didn't start even doing sliding scale. Do y'all all know what sliding scale is? Okay. We didn't start treating sliding scale. This was back in the 70s and 80s. We didn't start treating sliding scale till the patients were over 200. Evidence-based practice has now shown we need a tighter glycemic control. Too much of a good thing. Remember when I asked you, you said we need them, and I said, well, what about if we have too much of something? Too much of anything, of a good thing, is bad. So evidence-based practice has shown that we need a tighter glycemic control, that letting that blood sugar, now it's about 120 and 150, depends on whether they're on a tight or a moderate scale, because they have different tiers of sliding scale. We've decided that people whose blood sugars run in that range in between that we used to, like 150 to 200, that blood is too rich in sugar, and it's damaging the microvasculature. Whether it's the eyes, the toes, you know how the diabetics all have like neuropathies, and that sugar, too much of that sugar is damaging. They're having retinopathy in their eyes. So evidence-based practice has said we now need to start treating these people. We need a tighter control over that. The old A1C, what's the normal A1C? No, not 7. What'd you say? I think it's 5. I think when it gets above 6, they start, about 6.5, exactly. They start worrying about it. Back in the day, it was 7. And so what is an A1C? That brings up a good point. What does A1C stand for? Glycosylated hemoglobin. All right, you seem like you know what it is. Tell us what an A1C is. How do you know that? Besides that, what'd you say? Okay, great. Well, tell me what you know about it. Exactly. It's kind of like, exactly. I like that. It's kind of like, you know, like when I was in the military, they would do random urine drug screen. I remember one time I was in the clinic, and I remember one time our whole clinic, we had it for like 3 months in a row, and I was getting a little paranoid, you know. But if you really want, I was like, geez, are they looking for somebody? It's random. Like I didn't have one for years, and then all of a sudden. But it's kind of like if they're looking for drugs sometimes on somebody, they'll cut their hair. And they'll take a clip. You've seen that on the forensic files. They'll take a clip of their hair because the hair doesn't lie. Well, we'd be in trouble with you. But they find another way. They do an A1C for you for drugs. But no, they do, because it can show like exactly when somebody was like how long they've been on the drugs and stuff, because some drugs do leave the body. But the A1C, it's right. It kind of gives you like an average of like, I think it's 3 months. So she's right. She brings up a good point. You can't cheat. So what I want you to leave with about glucose is that hypoglycemia is an emergency. And I want you to know that now these days we have a tighter glycemic control. It's kind of like blood pressure. You don't want your blood pressure to be, when your blood pressure is normal, your vessels are relaxed. When your blood pressure is high, they're constricted. You would rather be normotensive, okay? You would rather be somewhere happily in between, closer to the relaxed. Because when those blood vessels contract and release and contract and release, the little things break off and they crack, the little lining, and then the sticky platelets coming through, and you have problems. So you're better if you can try to maintain your blood pressure, you know, not forget your blood pressure meds. And it's the same thing with the glucose. You're better if you can maintain it, your vessels, all your microvasculature. So chloride. The normal chloride, 95 to 108. It's the major anion in this extracellular fluid. Don't need you to remember that. It's a major component of stomach fluids. I'm sure you've heard of that. Hydrochloric acid. It's a buffer in the oxygen-carbon dioxide exchange. And we'll talk about dietary supplements in a minute. BUN. What do you think of with your BUN? Kidney. You'll learn more about the BUN and the creatinine when you study renal. My values are kind of different. I do 10 to 20 for the BUN, but in my head for creatinine, I do 0.6 to 1.2 because it doubles. It's just easy for me. But Pagana has 0.5 to 1.2. So you will learn more about that. You've heard of creatinine clearance test, and it's a greater indicator of renal failure. But you can also have it elevated if you're just in acute kidney failure. Hopefully it'll go back down. Although if acute kidney failure is not addressed, you could go into renal failure. And the BUN. Now, typically in a renal failure patient, and I'm not going to touch a whole lot on this, typically in a renal failure patient, they're never going to be normal. Does that make sense to you? They're never going to be normal. I can't say that for the glucose and the diabetic, because when they're taking their medicines, they can be normal, but they're never going to have a normal BUN and a creatinine when they're a true renal patient. All right, carbon dioxide, and this is venous because we have a different when we're talking about arterial blood gases, 23 to 30 milliequivalents. Calcium, I just say 9 to 10 in my mind, but Pagana has 9 to 10.5 because 9 to 10 is easy for me to remember. So calcium, primarily found in our skeletal system. Does that make sense? You remember calcium in your bones, so it's not going to be as high in your vasculature. So calcium is going to be primarily found in the skeletal system. It is a cation. It's responsible for our skeletal maintenance. It regulates muscle contractions, and I'm thinking of specifically cardiac, neuromuscular function, cardiac function, Also plays a role in blood clotting and activating enzymes. So what do you think about calcium when you think about the elderly? Okay. So is there any ways that we can help with that? Weight-bearing exercise is low, but you're right. Walking is probably the best exercise you can do because stress puts calcium back in the bone. Let's just put it in a nutshell. Anything that's got some calcium, and all those calcium supplements out there, like one says they're better than the other. But women have a tendency, as they get older, to lose, and not just women, but more women probably. But you see the little old people walking, and they've got the scoliosis. And okay, let's see. I didn't hit on magnesium, but I'll tell you a little bit about magnesium. It's 1.3 to 2.1. It's found in the skeletal system also. When I think of magnesium, I think of the heart also. I think of torsades. I don't know why. It helps operate the sodium-potassium pump. All right, the complete blood count. Have you heard of a CBC? What color tube does? Well, first of all, what color tube does this one? What'd you say? Green? Green. What else? What's another color you might see it in? Red, right? Sometimes red. I'm talking about this one. If you're drawing labs, you might see this one in a green or a red, or sometimes, aren't they marbled or something like red and black? Or, yeah. This, what are you going to see? What color? Purple. Okay. This will have a, it's either sodium citrate or it's EDTA. I can't remember which one's in the purple. Sodium citrate. And it just keeps it from clotting. So if you're drawing a tube on a patient, if you'll notice the purple top tubes and the blue top tubes, this is hematology, the purple top. They're going to have a little line. You have to fill it up to that line at least because, where are you going? Citrate. This must be EDTA then. Okay. So a couple of things. When you draw these, you've got a certain line. Like the red top, you might only get this much on somebody. If you only need an SMA-6, you could probably draw it on that. But a blue top, to really get a good value, you have to fill it up to that line because of the anticoagulants in it. And if you're going to work in the ER, anybody here want to work in the ER or works in the ER? Or if you work in ICU, just my suggestion, because I used to work in the ER and I've worked in the lab. If a patient comes in the ER, the doctor orders a red top tube, I draw everything. And I label it, and we used to, this one I worked at Tulane in the ER, and we put it in a cup and we put it on the desk. Because inevitably he'd come back after he looked at the SMA-6 and he'd go, I want a CBC. Well, then you have to stick them again. But anyway, that's just a little bit about the tops. So you've heard about a CBC. The white blood count, 5 to 10. You can remember that. That's easy. The red blood count, it's a percentage, 0.2 to 6.1. The hemoglobin and the hematocrit, that might be something that you're going to hear about more. And it does vary a little bit with sex between men and women. So the hemoglobin, 12 to 8. Now, something I'd like you to think about when you think about hemoglobin and hematocrit. What does hemoglobin do? Okay, carries oxygen to our body, right? So, does anybody know the cutoff? And every hospital is a little different for when we're going to give blood. It's about 7. Some hospitals might wait till it's 6. Some might do it at 8 if they're real conservative. But in general, if you're a thinking nurse and you get your lab work back that morning and your patient's hemoglobin has dropped and it's now 7, you want to call that doctor before he makes rounds and say, Miss Jones, hemoglobin is now 7. Do you want to give her any blood? Hematocrit, and we look more at that than we do the hematocrit because the hemoglobin is what gives us our oxygen carrying capacity. God bless you. Hematocrit, 37 to 52, and then platelets, 150 to 450. Okay. Just a little overview of osmosis infiltration. Thirst mechanism, examples of how osmosis helps maintain homeostasis. feeling of thirst causes activation of the brain cells. And it just shows this little person getting thirsty and drinking water. And it adds to the cushion in your joints and your muscles. And then she has another picture up here. Everything that plays into the thirst mechanism. And a little bit here about osmosis and equilibrium. So just another little picture. Let me see what I have next so that I can decide what I want to do. Okay. Capillary level, blood pressure, and your capillary bed, and it just talks about arterial side of the capillary bed and the direction of filtrate and fluid solutes and the interstitium. What is interstitium space? Yeah, it's in between. So it says filtration, pressure changes within the capillary bed. On the arterial side, because you have your capillary and you have your venules and your arterioles. On the capillary bed, on the arterial side, the blood pressure exceeds the colloid osmotic pressure. Arterial pressure is always greater than venous. It should be. So the arterial blood pressure exceeds the colloid osmotic pressure so that water and dissolved substances move out of the arterial capillary into the interstitial space. On the venous side, the pressure is low so that the water and dissolved substances move into the capillary. And that makes sense. Ooh. And then this is just a slide she has on active transport. I don't want you to memorize that. And it just talks about the sodium-potassium pump. Look how fancy she gets. Okay. Let me see. All right, before we get into the case studies, what I'd like you to do, and we have a few minutes before we take a break, I would like you to get into, just with your neighbor, and I would like you to come up with some dietary sources, and I'm going to go back to the slide of our electrolytes. You know, it's important when you do teaching for your patients. So, do you want to break it up into different groups, or do you want everybody do all of them? How about if we just break it up into the people in the back, y'all do sodium. The people in the middle, y'all do potassium. And let's see, we all know glucose. Just some dietary sources. And then y'all can do calcium. And I will let y'all do magnesium in the back and chloride in the front. So just take a few minutes and write down some dietary sources. And then we'll take a break.